This is section 12.1. We're going to be talking about sampling, frequency distributions, and graphs. Statistics, a method of collecting, organizing, and analyzing and interpreting data, as well as drawing conclusions based on the data. There's two different types. We can talk about descriptive statistics, collecting, organizing, summarizing, and presenting data, or inferential statistics, making generalizations about and drawing conclusions from the data collected. So this is just describing what we know. This is making predictions based on what we know. Population, the set containing all the people or objects whose properties are to be described and analyzed by the data collector. A sample is a subset or subgroup of the population. A representative sample is a sample that exhibits characteristics typical of those possessed by the target population. We have a group of hotel owners in a large city, and they decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. Describe the population. Well, the population is the citizens of the city. It's not the hotel owners. Those are the ones who are doing the survey. It's not the citizens who are gambling. It's the citizens of the city. It is suggested to survey all the people at 6 of the largest nightclubs in the city on a Saturday night about their opinion on casino gambling. Is that a good idea? When we take a sample, we want it to be representative of the entire city, of the entire population. So if we ask people at 6 of the largest nightclubs how they feel about gambling, they would most likely say that they are for casino gambling. On the other hand, if you look at the 6 biggest churches, if you look at the 6 biggest supermarkets, if you look at, other areas of the city, they may not have the same opinion on casino gambling. So you need to have a fair survey. You need to represent the entire population. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected. Identify each element in the population. Assign numbers to each element. Randomly select numbers. Assign the elements in the population who have those numbers to the sample set. This is one way of getting a random sample. Which of the following is the best way to select a random sample to find out how the citizens feel about casino gambling? Randomly survey people who live in the oceanfront condominiums. No, probably not. Survey the first 200 people whose names appear in the city's telephone directory. We need to represent everybody in the city. What about the people whose names begin with a W? Randomly select neighborhoods of the city and then randomly survey people within the select neighborhoods. Yes, this would be the most likely to get a random sample. Frequency distributions. It's a way of evaluating data, consists of the data value and the number of occurrences in the sample. And so let's look at this. This is a way of organizing information. If I were to write out all the numbers that I have here that's represented by this table, there would be a lot of numbers. There would actually be 35 numbers. What this says is there's 1 10. This says there's 2 11s, 5 12s, etc. So the reason why we don't write them all out is because it would take a long time. So most of the time information is organized in a frequency distribution. So anybody that has a maximum age growth of 10 is grouped together with all the others that have maximum age growth of 10. or age of maximum growth, sorry. Test scores for a class of 40 students. Group their frequencies into classes that are meaningful for the data. Well, grades are usually 10% or 10 points. So the largest or the smallest number is 40. So we're going to use classes of 40 to 49, 50 to 59. When determining classes, you don't want to have too many classes. This has 6 classes. That's a good number. You don't want to have 30 different classes to try and keep track of. So you look to see how many are between the 40 and 49. You count them up. I see a 47, and I see a 45, and a 43, and maybe there's another one, but I don't see it. So there are 3 that are in the 40s. You would do the same thing for the 50s, the 60s, etc. And here we have a frequency distribution table. Also, when you make your classes, it's a really good idea to make them the same size. There are occasions when you want to vary the width, but only on the ends. That's to allow for what we call outliers, people who are way far away from everybody else. This is an example of a histogram. It is a bar graph with the bars that touch. Bar graphs, bars that touch, can be used to visually display data. So this is an example of a bar graph. Frequency polygon. Despite the picture, I want you to pay attention to this. Despite the picture, you do not draw bars for a frequency polygon. It is not a bar graph. It is a line graph. This tells you where to put the dots. The dots are the midpoint of each bar on the histogram. So you put a dot here, you put a dot here, you put a dot here, you draw your lines connecting the dots. Do not draw the bars when you do a frequency polygon. Stem and leaf plots. Most of you guys, I think, are familiar with stem and leaf. So the numbers on the left would be the tens place. So I don't know what the smallest number is, probably 40s. And then we've got a 47, so we would put a 7. And we've got a 43, so we would put a 3. And a 45, so put a 5. When you're doing stem and leaf plots, even though technically the numbers do not have to be in order, I'm telling you to put the numbers in order. Grading these stem and leaf plots when the numbers are not in order is a nightmare. I don't want to have to keep track of those numbers. I want you to put the numbers in order so that I can actually grade it correctly. If the numbers are not in order, I'm going to mark it wrong. So what this information tells you is that we have a 47, we have a 45, and we have a 43. We've got a 57, a 54, a 56. Again, reminder, the numbers mathematically do not have to be in order. But I'm telling you, for your homework and for your test and your quizzes, you got to put the numbers in order from smallest to largest. So instead of 753, you would put 357. Deceptions in visual displays. Graphs can be used to distort the underlying data. For example, if you look at the scale, this makes it look like the poverty rate increases rapidly. You change the scale, this makes it look like the poverty increases very slowly. Things to watch out for. Is there a title? Are numbers lined up with tick marks? Has the scale been varied to create more or less dramatic impression? Are there too many cosmetic effects, drawing attention from or distorting the data? Are the data equally spaced time intervals? Bar size is scaled proportionately. Is there a source that indicates where the data is from? Was it a random sample? Does somebody have an agenda? Are they trying to make a special case for or against something? This is an example of a misleading graph. If you look at the shadows, it makes it look like the shadows, the uh, square feet of the single-family home is increasing linearly. If you actually look at the numbers, that's not true. One of the things is there's a 20-year gap between 70 and 90, but there's a 14-year gap between 90 and 2004. Also, if you look at the house itself, this one looks huge in comparison to this one, but that's not. It's kind of distracting. It's a cosmetic element that distracts from the information. Your homework is 2 through 20 even.